Okay, welcome everyone. Let's get going. So this is the second official session for OAuth work group. And let's get going. The note obviously applies here. Hopefully you're familiar with this already. Um, hopefully you're already familiar with those steps too. So I'm gonna skip those. Let's see. These are the sessions that we've talked about. This is the update, the Monday agenda, and the Thursday agenda. So um, we have a number of topics that Peter, with the help of Philip and Daniel, maybe we'll talk about device code flow. Vittorio with Brian in supporting mode. We'll talk about step-up authentication. Daniel then will talk about libraries, and Daniel will finish with Pixie in security BCP. This is a discussion that we had yesterday in a side meeting. We just want to recap that and make sure that work group is aware of that discussion. Any comments, questions about the agenda? Okay, let's get going then.
Okay, everybody can hear me all right? I'm going to take the microphone. So first of all, maybe while everything gets ready, my name is Peter Castleman. I am really delighted to be here. This is my first IETF, so it's sort of a really momentous moment for me. I actually want to thank everybody in this room and in this working group for the welcome that you've extended and how welcome you've made me to feel over the last couple of days. Thanks for entertaining my many questions, and I really appreciate it, and I've just enjoyed it so much, just working and collaborating with all of you so far. Okay, next slide, please. So maybe to start with, so I'm going to talk about device code flow and some of the exploits that we've seen that uses social engineering techniques that allows adversaries to really abuse the protocol and gain access to resources when they really shouldn't. And on the one hand, right, it's very easy to look at social engineering attacks and to say, well, that's just social engineering. What can we do about it? But I actually want to challenge us a little bit. I read this quote recently. There may be more that we can do. And so what I want to ask folks as we talk about this today is maybe just stretch a little bit beyond where we may have traditionally thought about where the boundaries might be and how we can go a little bit further, perhaps. Next slide. Thanks, Rafat. So we'll talk about, I'm going to just briefly talk about device authorization grant. Some people may not be familiar with it. I'll talk about the exploit patterns that we've seen, and we'll talk about that, and also just look at it. It's not like that RFC 8682 doesn't have any security considerations. It's not like it wasn't foreseen, but maybe we can do a little bit more and give more guidance on this topic. And then what I'd love to do is maybe talk a little bit about what we could do and what we should do. Also, while we've been here, Philip has also offered, he's come up with some additional ideas around social engineering attacks related to device code flow, so he'll share some of those insights. And Daniel has a demo. In case folks thinks this is not real, he'll show a little bit about how this actually works. So next slide, please.
Now.
Right, so next slide. So what is device authorization grant? So it's really a protocol that allows devices that lack a browser or input constraint, right, where it's difficult to input text, to be part of the OAuth ecosystem and to participate in the and obtain access tokens and refresh tokens. Next slide. And they're really for devices like this, right? This picture is something they're for smart TVs, or that was the original intent. They're for smart TVs, picture frames, printers, right? Devices like that. And so next slide, please. So if we think about sort of the main participants in this for a typical flow, you have your authorization server, your endpoints, you've got your consumption device, and your authorization device. And it typically starts with, next slide. you get and you display a user code. You also get a device code. You get the verification URI. The next slide, please. The user on their authorization device scan or enter the code. Next slide. They then authenticate and authorize, right? And that can be a multi-factor authentication, which is great. So you can have really strong authentication on this flow. Next slide. And then the consumption device ends up retrieving the tokens, the access token and the refresh token. Next slide. So really in a nutshell, right, you have this flow where you start a session on one device, and then you authorize on a second device. And next slide. And the benefits. So you can do authorization for devices with limited input capabilities. It's really handy. It's really easy in some ways. And you can also do this with strong authentication using a personally trusted device. Next slide. But this is the problem. Mind the gap, right? So the challenge that we run into is, next slide, please, is that there's this thing, there's a kind of a session transfer that happens here. And there is no protocol between the user's authorization device and the consumption device, and there's no way to establish that trust relationship. And it's not a back and forth, it's a one-way, right? And really our defense here is we are relying on the user to make an informed decision, and that doesn't always work, right? We, as individuals, people in this room, of course, do not have this problem. We are very good at spotting these attacks,
No.
but
Not really.
or maybe not. But there are a great many people out there where this gap is being exploited. And so, next slide, please. So let's talk about how this opens the door for social engineering for a moment. Next slide. So now we have I'm not sure if that is that's our adversary, and they get control of a device. Let's call it the attacker control device, and they can access and they can get a code. These are an attack pattern that we've seen in the wild. It's been documented. I shared some of the attacks that's in the public domain. So it's it's a real thing that happens. So the attacker ends up, they get a code, and next slide. Next one more. And what they then do is they end up, step number 2, they change the context. And they do this in very clever ways, right? They may obtain a device, and then they may send you an email or a text message. And the text message will say something like, hey, if you want to continue watching Netflix, please enter, you need to re-authenticate, right? And of course, these things happen occasionally, so people do it. Some of them are even more devious, right? They'd say something like, hey, you can get 6 months free of Netflix if you go and enter your promo code, right? They don't even call it a user code. Sneaky, very sneaky, right? So there's all sorts of ways in which the user can be tricked into entering these things, and they scan and they enter the code. I have a bus stop up there, and it's not a... there has even been attacks, I think, in New York City that sort of follows the same pattern with bikes, rental bikes, where somebody took a QR code on a bike, copied it, put it on another bike. When the customer came along, scanned it, it didn't unlock the bike, but it unlocked the original bike for which the QR code was printed, and the thief made off with the bicycle. Daniel, actually, when we talked about this, shared this attack with me, and it sort of just emphasized how tricky it is when there is no authentication or no trust relationship, right? When you have this gap when you're transferring a session. So now the user scans the code. Next slide, please. And they authenticate, they authorize, and the sort of the tragedy of this is even if you had multi-factor authentication deployed, the user would still complete the authentication, right? The attacker is not trying to steal the password or the authentication credential. They are just trying to get the user to say yes, right? And then next slide, they end up retrieving the tokens, the attacker retrieves the tokens, and now they have an access token and a refresh token. And depending on what's in the access and refresh token, they may have access for a very long time, maybe to something as simple as a consumer service or a bicycle. But it may, that extends to other services that uses the protocol as well. Next slide, please, Rafat. So basically, if you think about this, it's sort of a classical what we used to call man-in-the-middle type attacks. You initiate the session, you retrieve the code, you use some social engineering technique to change the context. And this attack sort of generalizes. It applies to other protocols where there is an air gap, right? Some versions of SIBA might be subject to this. Some of the work we're doing with things like SIOP and OpenID Connect may also be subject to this. In fact, whenever you're scanning a QR code, this is something to think about. Next slide, please. And here are some examples I thought I'd add just to sort of give people a flavor, right? Would you say yes to any of these things, right? Hey, here's a document, just enter your access code. Or, hey, you're about to be logged out. Do you just want to just make sure that you keep having service, right? Or, hey, your security department or your company has made a change and you need to take action. Otherwise, you won't be able to do your job. These techniques are, and then there's the bicycles, right? So these are all ways in which you can change the context. And there's many more, I'm sure. Rafat, next. Thank you. And in all of this, right, our defense right now is this mythical creature I call Homo securitas, who is a security expert. He understands how the protocols should work. He can detect these attempts. He is so focused on the current context. He knows exactly what's going on around him. But they're a rare species, right? Instead, next slide. This is really a Homo sapiens, right? We need to help Homo sapiens here. They're really expertise elsewhere, right? They're very smart, but this is not their area. They're busy, they're in a rush, they want to help. They're often worried about breaking things, right? And so what can we do? I think the question is, as I was looking at this, how do we help them to make fewer decisions? How do we help them to make better decisions? And when they make a bad decision, right, how do we protect them? And how do we provide guidance to implementers of these protocols to not just implement the protocol, but actually take into account this attack vector so that we have safer implementations. Rafat? So, of course, right, RFC 8628 isn't silent about this. This was something that was considered. So next slide, please. So this is the entire section on remote phishing. And really, I'm going to sort of summarize, right, 2 recommendations around better UI, right? So that there is some acknowledgement there. And then there is something that says, okay, if you made a bad decision, to limit the risk, just limit the lifetime of the tokens, right? So that it's not a forever problem. And so that's the extent of what we're recommending for protecting against phishing right now. Next slide, please. But it's not all, there's some others, right, that's also relevant. So there's a section on non-visual code transmission, and it really sort of talks about proximity, but really proximity in the context of non-visual code transmission. And it's not in the context of phishing. And I think this is actually a valuable and useful one in the context of phishing, and putting some more emphasis on that might be good. Next slide, please. The other thing in the security consideration section is it does talk about there's a topic called device trustworthiness. So another thing to think about is, what if you only allow trusted devices to participate in this flow? Which may not always be practical, but if we could do that, that could be another solution. But again, the guidance that we have today is really more about considerations of malicious authorization servers. There's a sort of a comment that says there's 2 devices. But it's all, and then it says, well, you need to trust the device provider, which is good, right? We should, but it doesn't really tell us more about what that mechanism should be. And that may well be out of scope of the protocol, but maybe that's a consideration that we want to provide more guidance on as well. So that's what we have today. Next slide, please, Rafat. So what else could we do, right? So there's some ideas that's come up in discussions with Daniel and Philip and many others in this room even. So next slide, please. So one is looking at proximity, right? Christina, I think you're familiar with this stuff as well. You would have seen versions of this in some of your work too. So, you know, could we look at introducing more guidance and mitigations on how to use proximity, not just pointing out proximity, but how we might accomplish that, both for the user experience, but also in terms of mitigating some risk on the back end. You know, do we need to give guidance on content filtering, right? If you're deploying device code flow or device authorization grant, should we give guidance about the need for having content filtering solutions in place? Additional metadata, token binding, right? So if somebody manages to obtain access and refresh tokens, do we want to at least make it so that they cannot exfiltrate the tokens and use them in lateral attacks on other devices, right? Is there some additional hardening that we want to do there? Trusted devices, I already sort of alluded to. And then there's even work that's happening, in OA system that may be relevant, right? So do we need to think about things like secure QR codes, right? Is there a solution that can help there? So these are some of the examples. There might be more. I fully expect that people in this working group have many more ideas that we can add to this. These are just some early beginnings. Rafat, next slide, please. So another thing to think about is, you know, one of the comments when you, and sort of it's on the mailing thread at the moment, is, well, you really shouldn't use device code flow in certain settings, right? But just like our customer or the end user is busy, the engineer sometimes also is busy and is not an expert in the field either. And so giving some guidance about, you know, when you need to have these cross-device type flows, giving some guidance about which protocols to use then, a kind of a protocol selection guide. That might be something else that helps. And it's true, right? The engineers can't just read all the different protocols and decide, or they can employ an expert. But again, right, if we as a community can make some recommendations, that could be another potential solution. So what should we do, right? If we go to the next slide. So, you know, there's some options here, right? One, we could say we'll do nothing. I'll remind you about the first slide I put up, which is, you know, maybe we should do or could do more. You know, a simple thing is just more implementation guidance, threat models, risk assessment frameworks, even user experience guidance, right? Profiles, recommendations, and so on. You know, maybe there's new protocols that we need to look at. CIBA is one of those that's interesting, but you know, may actually be subject or may actually be vulnerable to similar exploits. And then, you know, any other options, right? I think that's part of why we're bringing it to this audience, is to see if there is some other ideas that people might have. So, Rafat, I think we can come back to this slide later. I do want to give Philip an opportunity to maybe come and talk. So when Philip and I spoke earlier today, he mentioned that he sort of he saw another kind of social engineering attack and related to this protocol. So I'm going to hand it over to Philip to talk about his insights as well. Thanks, Philip.
Thank you, Peter.
Now I need to remember which one is the name of your slide. I have a long list of slides.
This one.
This one?
Okay, thank you, Peter, for making us giving us a good summary on how device flow and device authorization grant works in general. there was one very important piece that you mentioned, and that's the use of QR codes. And there is a class, or there is a certain attack that is ongoing, that is possible to exploit at the moment, which abuses the fact that not everybody uses those QR codes. Let's have a look. I want to point out the textual versus non-textual nature of the protocol. On the left side, we're asking the user to go to his other device, enter a string, and then enter another one. On the right side, I'm asking the user to pick up his phone, scan something which gets translated into the exact same URL and the code already embedded, and the user only has to compare at the end when he opens up the QR code with his browser. They only need to compare that the code that he sees on the phone matches the one that is over here. And why is this important? We can go to the next slide. Before I go why that is important, this non-textual thing was brought up into the RFC as an optimization. And we have a text there that says that with the optimization that the user does not need to type in the user code. The bigger optimization actually is that they don't need to type in the actual URL. And let's have a walk through why. Because let's imagine that the end user mistypes the verification URI, so that's the URL that I was told to go to. Or I just entered it into a search engine, because that's a thing now where the URL bar is overloaded with multiple functions, meaning that I will either land on a phishing site directly, if it's a well-known provider of, this is a device login, or I will land on a search engine result page full of landmines, paid ads, and search engine optimized phishing sites. I will enter my user code as I'm told by my TV, for instance, and instead of being presented with, hey, confirm the code and being able to log in, it tells me I should I should call a number, where a scripted scenario will take place. An agent on the phone will first ask me for an email address, and because I'm on the phone with him, it's really easy to make me distracted as he walks me through a password reset flow, where he asks me to confirm a code he just sent to my inbox, which I'm happily gonna give him because I just want to log into a popular VOD website. Who knows? As I do that, the agent is now authenticated. They can run the rest of their scam. They can buy digital products. They can attempt to upsell fake services to me, so to directly extract money out of me. And the ridiculous thing is that at the end of this all, when they're done, they're still going to log me onto my TV. I'm very happy because I can finally watch the TV show that I was about to log in. And the detection of all of this is delayed. Let's move on. Thank you. So the key points here are that the end user actually did initiate the authorization flow. It is, their target to log in onto the TV. It was not the attacker. The user has a legitimate stake in completing the flow. Improving consent confirmation screen on the other device does absolutely nothing because I will never see it. All I see is communication on the TV from the manufacturer or the developer of the application, and everything else is in control of the attacker. And I'm actually satisfied at the end because I logged in and I, walk away with my account details either stolen or out of a couple $100. Yes, this is an end user problem. There are post signs along the way that I choose to ignore, but we can still do better, because if we prefer non-textual code transmission, if we did not offer the hey, enter URL in the first place, this would not have happened. Likewise, if there were actual password reset links and that password reset codes, this would also not be possible because they could have never asked me to, can you please repeat the 64 hexadecimal string that I just sent to your email? That's not a thing. So question for the group for a future discussion after Daniel is done with his demo is, other than the QR code, is there anything else that is readily available and usable that we can offer? Thank you.
Thanks, Philip. Let me quickly switch. Do you wanna?
No, I was just going to invite Daniel up. Daniel.
Let me see if I can
Thank you, Peter. Thank you,
share
Philip.
the screen here. Share the screen. Yes. Oh shoot! I need to.
There's a security mechanism
Yeah, that is some security stuff that I need to
blocking the
like
screen
that.
sharing. Or maybe it's a phishing attack.
I guess.
Never know.
To reopen. Shit. Need to rejoin. Yeah. Sorry. Shit. Yeah, that's what I was worried about, right? Come on. Okay. Second here. This one. Start here. Oh, come on. Where's the video that you sent me? This one. This one.
Yep.
Okay. See. Yes. Complete. Share. Yes. Chrome tab. I don't know.
Share the whole
I
thing.
just share this. Not this one. Okay. Ready? Or should you
Yeah.
wait
If you,
inside that thing? Yeah.
if you could stop it here.
Yes.
Yeah. Okay, so this is just a quick demo to visualize what we're talking about here, because usually a screencast says more than 1,000 screenshots. So what we have here is on the right-hand side a wallet app that we're working together with in a project, in the ID Union project. And in the middle, you see a phishing site. So essentially, you have to imagine that you only see this part as a normal user. You go to a website and you want to use your wallet at that website. That website is, in this case, called attacker.example.com, but in practice it might have a name that is less suspicious. So you're at that website, you want to log in, you see a QR code, everything looks completely normal to you. You want to log in at that website. So what you don't see is that this is an attacker-controlled website. Maybe it's a compromised website. Maybe it's just set up specifically for that purpose. And the attacker is not showing a QR code that will log you in at attacker.example.com. But instead, the attacker has taken that QR code from another website. In this case, it's an Nextcloud login that also works with the wallet login. And the attacker has just stolen that QR code from there. You don't see that website. You just see that website. But this is in the background.
When you say that and this, just because
Okay,
people are
the red one is
red,
what the user.
Yeah.
Thanks, Rifat. So the red one is what the user sees. The blue one is what the attacker has opened on his computer on the background. So as a user, you see the red website, attacker.example.com, and now you can play the video, please. So you see that QR code. You want to log in. You open your wallet app on your device. That would be on your mobile device. You click on Scan QR Code, and stop here, please. You click on Scan QR Code, and on your mobile device, you see, do you want to log in? Do you want to provide some data to that website for the login process? And yes, you want to log in at attacker.example.com. So you click on yes and send and do and whatever. And the login is complete, it shows success. On attacker.example.com, in this case, nothing happens. The attacker could show thank you for your cooperation. What happened instead is that you can see on the left side, the attacker logged in or now has control over a session that is logged in under the victim's name in the Nextcloud. So as a user, you didn't see that an attack was happening here. Thank you.
Awesome. Thank you. Thanks, Daniel.
Thanks, Daniel. Rafat, can you show the last slide of my presentation again?
Yeah.
So back to the question about what we can do about this. Hopefully this is sort of a bit of an overview. I think you've heard from a couple of people who have come across this social engineering angle and some of the challenges that we run into with it. And so, yeah, I mean, I'd love to hear back from folks in this room, right? A reasonable thing that we can do, right? Is it worthwhile, right, to provide some additional implementation guidance on top of the device authorization grant to highlight some of these topics? Would it help, or is there other things that we should do? Should we really be thinking about other types of protocols or other types of solutions? And yeah, that's my question for folks in this room or online.
Okay, Tim.
Peter knows what I'm going to talk about. Tim Capelli, Microsoft. I just did, Mike, as you said it. Jeez.
I should just clarify, Tim is a colleague of mine. I didn't actually declare my affiliation. I am a Microsoft employee as well.
It's on your check. Yeah, I know, right? So I think I think we have to up-level the discussion to the use case. To solve the use case moving forward, in my opinion, the solution is WebAuth and cross-device flow. And that is an important distinction because we have to start that message now, because these TVs that are sitting here stay in people's houses for 7 to 10 years. But we imagine in the next 12 months, 6 billion devices around the world will have cross-device phishing-resistant authentication capability, right? And that's a huge, when this conversation started, that really wasn't part of the discussion. So I think I agree, everything about trying to reduce the risk with what's there today has to continue. That discussion has to continue, but in parallel, we have to start the conversation about getting rid of device code flow. And I think they intersect at a point where you can start to reduce the attack surface by reducing the scopes you're granted when you use device code flow. And those will drastically intersect, hopefully, in the near term. So yeah, I'm happy to take any questions on it.
Thank you. Any questions for Tim?
Yeah.
Justin,
go ahead. Justin.
How does it work?
No. Yeah. So yeah, like.
Yeah, so we have to be a little bit careful because it's still IPR protected, but more or less there's Bluetooth involved that handles proximity and key exchange, and then it's standard WebAuth from the client standpoint.
Okay. So okay, we're not gonna. Okay, so that's fine. Vittorio, go ahead. We'll get back to that. Okay.
Hi, Vittorio Octa. I think that the WebAuth feature is beautiful and bright and very powerful. But I think that there are stepping stones that we can use to get there. And in particular, right now, we have this section in which we say, use whatever you have to transfer context between the requesting and the authorizing device. And I think of it, we have an opportunity to be a bit more prescriptive. So there, Bluetooth is mentioned, and Bluetooth is also the thing that fuels this thing that Tim described. If we were to be more specific and say, okay, here there's a how in practical terms to use Bluetooth, we can transfer context from the requesting device to a co-located authorization device. And once you have that enshrined, and without mandating WebAuth, but for example, just saying when this happens, you open the system browser and you go to this URL plus code. At that point, you would mitigate the number of the challenges that you highlighted. And if it's standard, now you can reasonably expect hero apps like your Authenticator or Google Authenticator or the Oculus Authenticator or even operating systems can start doing this. Of course, other challenges, you still need interstitial dialogue saying this is happening. But I think it would be a significant improvement, not just from the security perspective, but also from the user, for user experience.
Thanks, Vittorio. Tony.
Tony Nedlin. So I assume you're talking about Google's implementation, and it really doesn't have much to do with WebAuthn at all. It's down in the FIDO level, so
To the mic, Tony, to the
so,
mic.
so it doesn't have much to do with.
No, he has a mic. He has a mic.
So it doesn't have anything really to do with WebAuthn. So it's all done in the FIDO level protocol underneath, and it's got severe usability problems, and this is one of the reasons why it hasn't been released, and it's still in what I would call trial. I'm not sure that this is the proper, paradigm to actually go in. It's, the Bluetooth does have some severe issues, and they do have some security issues associated with their pairing, or how they do the the quick pairing.
Thanks, Tony.
Okay, Justin.
Hi, Justin Richer. So the composed URI is something that I always hated about the device flow, and I helped write that paragraph with all of the considerations of don't just auto post the form and all of that other stuff, because I always felt that that was a bad idea. Because I think fundamentally here what we're realizing is that these are two very different interaction modalities. In one, we're communicating something that a user needs to be able to type, whether it's the pair of URI and the code, or just the code itself, would they get the URI from documentation or whatever. That is very separate from being able to have a URI with a whole bunch of stuff packed into it, or even like we saw in Daniel's demo, being able to send a long, arbitrary, untypable chunk of information to the user where we're not expecting them to copy and paste or to remember or to transcribe or anything like that. And I think our first step at this needs to be separating these and not treating these solutions where, oh, we're just going to send a whole bunch of cryptographic information over Bluetooth. Excuse me. That's not really the device code flow anymore, right? It might be using some of the mechanisms or something like that, but it's really solving this in a different way. And that's where I do agree with the statement where this nexus of things of saying okay, if you really do have to use the device code flow, then we know that that's got some severe limitations. So we're only going to let you do these particular things with it. And we're going to warn you, and we're going to send, notice that, hey, there's a new device on your account, and all of that other kind of good advice that we can actually give today, while still being able to develop these new paradigms and not pretending that this is just another way to expand the device flow.
Thanks.
Thanks, Justin.
Thanks, Justin.
Hans.
Yeah. Hi, this is Hans-Jörg. I have a more general remark. I'm not even sure it's in scope, but I'll try my best anyway. So there was something that rang my bell in Peter's talk, which was basically this observation that many developers don't really know what they do, or might be puzzled by what's available in the standards. And my experience actually from developer using encryption standards is that many of the stuff doing by crypto researchers is very much low level, and it's very hard to grasp actually how to apply that and what errors can be made. So my impression, this might translate a little bit also to things like OAuth and the processes involved. And what I actually would like to have, and I read that a little bit in user experience guidance, is maybe something like about design patterns in programming, standardized labeled descriptions of certain cases or error cases which are interlinked and help me navigate and relate a little bit how different things can be put together and which errors might occur if I choose a certain solution in that or that direction. That's all.
Okay, Tim.
Thank you. Tim Cabana, Microsoft. Sorry, Tony, I'm not going to let the room leave with what you said. That's not correct. There are we're guessing 2 billion devices that now have this capability over the past 3 to 4 months. And you are correct, though, that was not the communication to the phone was not WebAuthn. I think my point is that I didn't actually say verbally was that from an IDP standpoint, you don't need to implement anything special. It's just WebAuthn.
Okay.
Thanks.
Okay. Thanks, Tim. Peter, do you have any just last minute comments? Or I want to just summarize this after that and see what we have together.
Yeah, again, some great points. Thanks, everybody. Justin, I think your point's spot on. I do think these are separate things. I think that the point's been made. We have to secure what we have, and then we have to look for ways in which we can minimize the use of that and provide better alternatives. That's kind of my summary of that. I think the point around the way I think about engineers, right? They've got expertise elsewhere. They may not be security experts, and the rate with which OAuth is just expanding in the world and being adopted, expecting more people to become experts at this is not right. And so I feel like I'm hearing, yeah, we need to give more guidance and we need to help the developers with that. And yeah, I think that's kind of what I'm taking out of this, that there's interest in proceeding with this.
Yeah, absolutely. That's what I've heard too. And maybe if you have a proposed solution, also propose those solutions, right? So anything else, Peter?
So if folks are interested in this topic, reach out to me. Let's start working and figuring out how we shape a response here as a group and a community. Thank you, everybody. Thanks
Awesome.
a lot.
Thank
Thanks,
you, Peter.
Daniel and Philip as well for your contribution here today.
Thank you all. Yeah, that was a great presentation, great discussion. Thank you. Vittorio, my friend, come here. Yeah, let's see how we can do that. Hold on. Okay. Step up. Share. Where is Vittorio?
So now I did the request form.
I think I can hand it to you. Let me see. I just sent you the control.
Oh, yeah, look at this.
There you go. I don't have to do anything. Now I can go to sleep.
I don't know why no one did it before. It's ultra annoying to ask you.
Yeah. There you go.
All right.
Okay.
Buongiorno, everybody, and welcome. Thank you for taking the time to come here today and hear about Brian and yours truly proposal on dealing with step-up authentication. Step-up authentication is a pretty well-known problem which emerges in various circumstances and for which we have no standard solution. And we don't have interoperability, and that's the reason for which we decided to try to analyze the problem and see whether we can suggest a very essential way of dealing with that. So we're going to spend a few moments on the problem, which is well known, but still by due diligence. Then a few moments on the proposal, which is really, really bare bone, so shouldn't take long, and then we'll discuss. All right. So we know that there are organic ways of witnessing step-up authentication. So a client might ask for an initial set of scopes and then knows that it needs to call another method of API, and that API might require requesting a different scope, which in itself might require to do a step-up authentication. So those are the cases in which the problem solves itself. Let's say that the step-up authentication just occurs. However, there are a number of other situations in which the client can do everything right and use all the information at its disposal and successfully authenticate the user in the way that the authorization server requests, and still the API might refuse service. It might say, you're trying to buy an item which exceeds your spending limit, and the item that you're trying to buy is not available at the moment in which you are asking for the token, and so the authorization server cannot do anything to reflect this heightened requirement. Or we know that it's fashionable nowadays to do continuous authentication, and so you might have risk engines or any other black box logic which might decide that the token that you sent is not enough. And today, unless you have some proprietary way of dealing with that particular scenario, you're stuck, because the client is just going to repeat the request to the authorization server, get the same token that it requested before, and be refused service just in the same way. So not great. Okay. So what we are suggesting is very, very simple. We are just introducing a new error code, which basically says authentication level was not sufficient. And then we are borrowing a couple of parameters that are already in use in OpenID for ID token requirements. And we're basically saying, okay, resource server, you can specify in your challenge sending back this error code also the ACR that you would like, or the list of ACRs that you're okay with for the client, so that the client can turn around, repeat the request to the authorization server, and include those parameters. Now, in the case of OpenID, when you use those parameters, again, affecting the ID token, in this particular case, we would extend the semantic to apply to the access token. And also, OpenID is lax. Let's say that it says, well, authorization server, if you want to do it, but you are not forced to. Instead, in here, we would add something in the metadata, which for the authorization server to comply to this particular flow, it would commit to actually do its best to comply with a requested ACR. This system would be compatible with existing mechanisms we have today, such as the scopes. Like today, we have insufficient scopes. And so we would be perfectly fine if you happen to be in the circumstance in which you need both to elevate your ACR and to request new scopes, to ask both things at the same time. And basically, now that we have the JWT profile, we can actually describe how to report the outcome of these different authentication in the form of an ACR claim. We can extend the schema of the introspection endpoint to also specify exactly the same claim. So we basically have all the various pieces of the solution available. And now the real power of this thing come into play, because I can show you a fantastic animation. So here you have a client, you have your resource server and your authorization server. Business as usual, I just try a get, I include my bearer token. But as it turns out, actually here, sorry, not very big. There is no ACR. It's just like standard token. And again, I'm using JWT just for simplicity, but you can perfectly have an opaque token that uses introspection. The resource server deems that the level of authentication reflected is insufficient, and so now it returns insufficient user authentication, and in this particular case, it includes only one ACR value. Of course, it could also include max age if necessary. It could also include scopes if scopes are also missing. And then at that point, the client turns around, goes back to the authorization server, and it includes the information about the ACR, which would not normally have been available, and which could be contextual to the particular request and the characteristics in there. And then authorization server will do whatever it deems necessary, hopefully trying to comply with my ACR, and assuming that the user successfully authenticates, we get our usual response, and this time we get reflected in our settings that we did comply with the ACR. And then at that point, we just repeat our request, and oh joy, we get back to 100. So the main advantage of this is that now we have an interoperable way of dealing with this scenario. We presented this problem in a similar proposal at the Auth security workshop last year, and the session was the most voted by the people, despite the fact that we did it at the very last moment. And the comments and the tweets, like the various reactions, were all like, "Oh wow, are you saying that this is not standardized yet?" Like, it looks like it's a problem which is fairly common, and also I know that some platforms already have their own proprietary solution, but it seems like whether it's solved this way or in some other way, the step-up problem is a problem that people have. So one advantage would be we now have an interoperable way of doing this. The other is that it is a relatively small step. We are not asking anyone to start implementing eventing, event buses, event syncs, asynchronous stuff, stateful stuff. This is ultra basic sending back parameters in the context of transactions that are already occurring. So we are not creating new messages or anything, and we are staying squarely within the extensibility mechanisms that the spec offer. And yeah, Brian, am I forgetting something? Thank you. Your praise is very important to me. So,
Okay.
look at all these people in the queue.
Okay, Steve.
clarifying question. Is ACR multi-valued in that?
I'm sorry, sir. Your name and your affiliation.
Later once it says so in the queue. Soon.
But the angle is,
All right. So if you flip back 1 or 2 slides, maybe.
I think I might have lost control.
No.
All right.
Can you
No.
give me back control?
Oh, come
I
on.
don't, I have back control.
So in that slide, it says ACR values. Is that it's a multi-valued? So you can request any of these.
Yeah.
This
Okay.
is a very good question. Yes,
Yes, it
yes. This the semantic is exactly the same as OpenID plus access token.
Justin.
So my question is really around why the resource server is the one that's caring about authentication levels as opposed to the authorization levels applied to the access token. Because there's this great blog post that says how the resource server is not the service that you're actually logging into. It has this whole metaphor with chocolate and chocolate cake. You may have read this one.
Yeah.
It's Vittorio's blog. If people didn't get that joke.
It's like giving
Um,
for my own medicine.
Yeah. So I'm just trying to see what the use case is here, where that's driving the RS needing or even caring about that information about the authentication level of the user at the AS. Because traditionally, once you get the access token, it's just whatever the access token is good for. And so, can you help me understand what's driving to this particular solution?
Absolutely, and thank you for the question, because it gives the opportunity for a useful clarification, which is we still care about the authorization in this case, and we are not trying to mess with what OpenID already does. This is similar to the use cases that we explored when we did the JWT profile, which led to adding the ACR claim in the layout. And basically, there are a number of scenarios in which the resource in itself has requirements about the authentication level of a user, still for authorization purposes. So it's not like that they want to mess with anything. It's more of like, if I am reading mails, I'm okay with username and password. But as soon as you want to send mail, I would like to know that the user performed MFA. Now, personally, I agree that it would be best if a resource server would somehow translate these in some other form, like, for example, scopes that reflect a different authentication level. But the thing is, we already have ACR, which already have a semantic which maps to MFA. And for people that build policies, MFA is an easy to grasp concept. And so requiring it somehow is something that happens very, very frequently. Like in real life, back in the Microsoft days, I had to do this all the time. But and actually, here, I would personally want to place in here also AMR. So going to the level of the method, but the guy with the pink mask is very much against. And he raised a good point that it would be brittle, because if you ask for something specific, then it's easier for break it. But the thing is that the developers I work with in practice, they ask for that. They ask for saying, I want to know if you used a smart card and not just that you used MFA.
So follow-up corollary question, if I may?
Go ahead.
That does beg the question, how does this relate to needing step-up authorization for additional scopes and things like that? And since you brought up AMR, what about vectors of trust?
So for scopes, as we mentioned, basically you can just return here the list of scopes that you want alongside with this. So imagine a merge with insufficient scopes. On vectors of trust, I let Brian Campbell to answer the question.
Well, you don't have to answer it now. Maybe if you don't have an answer now.
We can chat later.
Yeah. Later. Okay. George.
George.
Yeah. So I mean, I think for me, this makes a lot of sense. I think we should have some caveat that says this works where the resource server and authorization server are in the same domain, right? I mean, I think we're seeing use cases where, you get, authorization server issues an access token that works for multiple resource servers, that maybe not within the same domain, I worry that we don't have standards around ACRs. I have seen people use Justin vectors of trust tags as their ACR values, AAL1, AAL2 as the value that's being requested. We also have the EAP stuff in the OpenID Foundation that allows you to request hardware-backed phishing resistant authentication. So there is some stuff here, but I think there's some more guidance from a larger interoperability perspective that we're going to want. But within a single domain where the resource servers and the authorization server are sort of all run by the same company, I think this would work fine. And I do think there are lots of cases, whether it's time-based or otherwise, where APIs that are being invoked need to have some level of additional authentication, right? I want to know that you entered your RSA code. I mean, this used to be on eBay, E-Trade all the time, right? You go to do a trade, and it pops up the thing for your RSA token. Enter your code, right? And I think we sort of have to include that as sort of an authorization mechanism to Justin's question.
Thanks, George. This is a good point to mull over. I think
Vittorio, for the meeting minutes, I captured that the same domain issue, but I wasn't quite sure what the cross-domain use case, George, was. Like you're saying, this is not enough for a cross-domain use case, or?
Sure. I want to take, a token issued by, by a company that is, issuing tokens and use them at some completely other like think about a resource server that works with multiple email providers, right? Each email provider is issuing its tokens, right? And it may support multiple issuers, right? And those tokens are coming into its API. Now it needs to know what are all the different specific ACR values at each of those issuers and figure out which one to send, right? I'm just saying there's complexity there. So we could frame this in the context of, this makes straightforward sense in the context where the resource server and the authorization server are in the same domain, right? When they're not is sort of out of scope of the spec, unless we want to tackle that problem.
Hannes, can I reply?
Yeah, thanks for the meeting minutes.
No, of course. By all means. Great point. Interesting thing to think about. I think that the fact that ACR is by reference and is just a string, and both parties need to know what that means, is a natural scoping mechanism. Let's say that a resource server will say, I need these ACR, and that ACR can have been acquired only out of band while talking with a particular authorization server. And I think that might be enough of a scoping mechanism, because if there are more than one authorization server and they share the MyACR, like imagine that the gain folks actually succeed, and say that the gain profile has identity providers and authorization servers that follow the same model, and they share like ACR values, which have semantic in the context of that particular system. At that point, it looks like you might have more than one domain, but you might have good reasons to use the same stuff. So I take the meta point that people need to think about this, and they need to be probably mindful and explicit about how to scope it. Whether that results in being in the same domain, I think that we need to uproot the thing, like study it and see whether it's a conclusion or not. But in general, I agree with the premise.
Thanks, George. Brian, do you have a point about this discussion or something else?
Yeah, it was exactly that. There's some agreement on what the meaning and levels of ACR that's necessary. It might be on a pairwise basis, it might be on an ecosystem type basis, but there's nothing inherent about that would limit it to a single domain. So that I guess I do disagree with that characterization. The general idea that there's something needed to to work and a shared agreement about ACR, yes, but limited to the same domain is not the right scoping.
Okay, thanks, Brian. Philip.
Philip Skokana, Okta, not OUTH0, sorry. So very quick thing that, very quick thought that came into my head is that the client and the resource server will probably need to share some level of trust, or there needs to be some level of trust established, because otherwise the resource server can now turn and make the client do something that maybe it didn't want to do in the first place. This is just something, that came to me. If there's a rogue RS that the client is made to talk to, it can now turn back to the client and tell him, listen, just add these parameters. I'm not sure if there's anything in it, but it's just a thing to consider whenever we write up security, privacy, whatever considerations. The other thing is, it's great that there will be something else than 6750 that actually uses authenticate, because it will force clients to implement parsing it correctly. Thank you.
Thanks, Philip. I really like the observation, mostly because these validates using specific semantic for those parameters, as opposed to just say, let's have a generic property bug that we send back to the client and that the client mindlessly just send out. So that at this point, like the semantic of ACR values and max age and scopes is very well defined. And now, of course, the authorization server might still abuse it. And sure, the resource server can ask for an absurdly high level of authentication, but the point is they can do this already. Let's say that if they are getting a token from the authorization server, potentially they could say, when you call this method, when you ask for this scope, I want you to use this authentication level. So your point in general is well taken, that we need to make sure that we don't enable odd extensions in which we play stuff that allows things that are unexpected to occur. But I think that we can define the semantic of those parameters narrowly enough that that should be contained.
All right, Leif Johansson again. So I'll take this opportunity to remind about there is an IANA registry for access or authentication context class refs, which actually covers ACRs as well. That based on RFC 6711, I set it up years ago. And it has like all of the globally recognized context classes, like the EIDAS levels of assurance, stuff like that in it, and and a suspicious number of Swedish stuff as well. But that could be used. I mean, there are certain things that really should have global recognizability, right? And you dump stuff in there, and I think maybe it's time to go and revise that RFC and maybe update the IANA registry to make it a little bit more applicable to OAuth and OIDC. Anyway.
Thank you.
67.
This is Dave yeah, go ahead.
Hello? This is Dave Robin, representing BACnet, the Building Automation Control. So I've been evangelizing OAuth to BACnet people, educating them, the whole thing, token binding, client IDs, scopes, everything. Now it seems that we're throwing in an additional thing here that I have not been evangelizing to them. And the question is, you said, oh, I could use a different scope here. I have a read token now. I want to write scope as well, right? Why? Or I could have this generic email scope and get this different ACR value. So it seems like the permissions are no longer scope based. They're a combination of scope based and ACR based. It's a sort of this weird cross product or something. And I find that confusing. I understand your answer was, well, we have this ACR mechanism, so we'll use it, as opposed to new scopes. So I'm not saying that this is a bad thing. I was just questioning why not use scopes. What is additional scope not giving you that you need the existing scope plus the ACR value is effectively a new kind of permission?
So there are two various levels. So first, scopes are not necessarily only permissions, but they could be used as permission. In this particular case, scopes are typically something that you have at request time. And there are things that you are typically have in a third-party scenario. If you are a first party, potentially people use all this flow with no scopes at all. So at that point, you would be asking them to include scopes in a scenario in which potentially there is really no delegated flow. So technically, in terms of universal Turing machine, scopes have the enough expressive power to do all these.
Okay.
It's just that now I have to introduce them and basically have the same semantic I already have with my ACR with implementation that already react to this, because OpenID Connect already have this mechanism in which you can ask for this, even if you have no scopes at all. And the circumstance in which you needed to elevate do not include scopes, because the consideration is not statically calling to this particular subset of a resource. Is more situation happened, and so I need to ask for this. So in terms of clarity and in terms of distance from the implementation, this thing we believe would be clearer. And also the other point is scopes as a mechanism of a challenge has been in there since the very beginning.
Right.
And very few people use it because it's so generic that in the end, what makes the difference is the scopes that you are asking for and the particular semantic for your particular system. So just having the mechanism that sends a scope around doesn't make much of a difference. And despite our years in which we tell developers, do incremental consent, don't ask for everything up front, just at lunch, we were discussing the fact that in practice, the developers wanted to avoid these as much as possible. And so rather than asking for scopes when they need it, they ask as much as possible upfront,
Right.
so that
Right.
they reduce the number of prompts and the opportunities for developer to do something wrong. So sorry, to the user to do something wrong. So we believe that by being specific and by piggybacking on existing capabilities that are already rooted on those values, we will have a better shot at interoperability and implementation than with scopes, which so far could have done this but haven't done this.
Okay, well, it's similar to the resource indicators thing of preventing scope of use, where scope is abused to indicate resources, clients,
Yes.
all the other stuff.
It's a perfect analogy.
Okay.
Fantastic.
Great.
One second, Mike. Brian, do you have a point about this discussion? Go ahead.
Just one more thing, that a use case that's kind of near and dear to my heart that this fits better with is on the resource server side, some kind of anomaly detection or AI or whatever black box indicator or even signaling that it's receiving, that suddenly it decides a token is invalid, and wanting to be able to take the user, tell the client to take the user through a re-authentication flow to remediate that situation is something that is even harder to model with scopes. I think you probably could, but it's even more difficult than the kinds of static scope to authentication level. So just one more driver for being able to sort of independently express, hey, I need this user to authenticate again at this level and do it in this time frame to get access.
Mike.
Mike Jones, Microsoft. Reinforcing my friend Leif's comment, when we defined ACR in OpenID Connect, we already suggested that people should use the level of assurance profiles registry for the values. And I also agree with Brian's comment that the fact that there's mutually understood values doesn't imply that things are necessarily in the same domain. Right. Indeed, Leif's registry enables that to not be the case.
Yeah, as long as it speaks with it. I mean, that's enough.
Okay, thank you. Vittorio, do you want to wrap it up?
Well, as you have seen, the scope of this thing is pretty small. If you think that this is a problem worth solving, then the draft is out there. So if we want this to be adopted and work on it, reluctantly, but Brian and myself are willing to move this thing forward.
Yeah, I get the feeling from the room that there is interest. There is still some maybe confusion or still some something to clarify. So I would encourage you guys, Vittorio and Brian, to maybe update the document, take that input into consideration, maybe clarify those points, and submit a new version, and let's see if how we can move it forward next time.
I'll read the minutes with interest. I suspect that if you'd read the current draft, you'd see that many of those things are addressed.
Okay.
But there is always the possibility that some delta is to be managed.
We could also ask
Yeah, we could.
for reviewers of the document.
Yeah.
I think that's always good since now people are aware of the document. Like maybe you have a show of hands and I can scribble down a few. Robin.
Yeah. Okay. Robin.
Okay. Peter.
Philip.
Yeah.
Peter.
Hold on. Philip.
Peter. Anybody else?
Peter. Robin.
Yeah.
Did Leif raise his hand? Or
Okay. Yeah, just put it there. Perfect.
You don't want me to drop it? Okay.
Thanks, Vittorio. That's great. Thank you all. Okay. Awesome. Vittorio. Trying to. Daniel, you wanna? Okay. Just request it. Taken already? Vittorio. Vittorio, can you exit? I think you're still in control.
I'm still holding the.
Yeah. Oh, here, I got it. I dropped you.
You got it?
I forced you.
Oh, no.
Okay. Okay. Where is it? Which one? Oh, here.
No, this is not right.
Oh, not
Libraries.
Pixie. Not
Libraries.
libraries. Where is the libraries? State of clients? Yes. Yeah.
That's
Okay.
the one.
There you go. Take it away, Daniel.
Thank you. So today I want to talk about the state of the clients regarding Auth clients, obviously. Next slide, please.
Do you want to use the mobile device to
How does
advance
it
it
work?
yourself?
No.
Why? Why? It worked nicely for
Anyway.
Vittorio.
So
Oh, sorry.
my observation is that there's a lack of good, modern, and universal OAuth client libraries. And this is something we should address. This is something we should fix.
I give you control if you want to try it.
Okay, so that's in the same web interface. Oh yeah, got something here. This is
There you go.
There we go. Excellent. This is great. Yeah, fantastic. Okay, so what is a good modern universal client library? So what could it be? Let's say.
I'm sorry, is the scribble panel part of the slides?
No.
Can we close that?
There we go.
Awesome.
Thanks.
It was just there to annoy you.
I would say
Great job.
a good library is one that follows the latest security recommendations, is one that feels native in the language or framework for which it was developed. It is hopefully also maintained and documented, especially so both parts are important, maintained obviously also for the security part, and documented also because so you can learn what the library actually supports and what it does and how to use it. As a modern library, I would say library should support at least a certain set of security features like Pixie. It should support methods for asymmetric client authentication, maybe MTLS. And maybe, big question mark, it should support things like Auth 2.1 or FAPI. This could, so even if we don't say, okay, all libraries need to support FAPI, that would be a bit strange, obviously. But maybe these kind of profiles can give us a direction in which way to go, what a good library could support. And universal means that it is not tailored towards a specific use case or specific vendor, specific API, because many of the OAuth clients that you find out there are written for sign-in with Google. Maybe they support Google, Facebook, and I don't know, Amazon, whatever. So that's not a good library if you want to use the library as something completely different. It should not be limited to certain use cases as far as possible. Obviously, a library on a mobile device would be different from one with a web interface. Maybe it could be the same library. But apart from that, it should not only cover very narrow use case. Yeah. It should be very configurable for various feature sets, ideally, so it should not assume the same feature set in all the use cases. For example, I saw that many libraries claim to support OAuth and OpenID Connect, where in reality they just implement OpenID Connect, so you sometimes cannot even switch it off. That's not a good thing. Ideally, you just throw some issuer URL at the library, and the library configures itself because it can read and understand server metadata. This obviously also requires that the authorization server provides server metadata.
Daniel, do you want to take comments now? I think it's a CBTOR on the, or you good? Okay. Okay.
Yeah, maybe we take the comments afterwards. Okay. So what's the experience in practice? When I say experience in practice, I mean my personal experience, and that is at yes.com, where I help customers to implement yes.com, which is more or less a FAPI2 profile, so all standard features. Yeah, in practice, this means that there are some libraries that you can use to implement what we are doing, like Philip's Node.js library works well. We have a demo for that on our website. You can just use that. It's a few lines of code. Works really well. There are some other libraries, like in Java, the Nimbus library, but apart from that, there's not much else. Most of the time, that means that our customers end up with custom implementations. So we have a developer guide. We tell them how to make certain requests, how to process responses, and they have to implement this step by step. The experience is, for me personally, that I cannot point developers to good libraries because maybe I just don't know where the good libraries hide. But my impression is that it's really, really hard to find out what are the features that the library supports. Is it even a client or server library? Some just say, okay, we implement OAuth. Okay, what exactly do you do? What are the specifications that it supports? Is it just RFC 6749 and 6750, or is there also Pixie? Is there anything else? Not so clear often. Did the authors have a look at the latest security recommendations or not? This in particular is often just not documented. So you have to dig into the code and figure out whether they, I don't know, would even handle things like an issuer in the authorization response and stuff like that. Many of them are incomplete, so it works for sign-in with Google and a few others, but apart from that, nothing else. And there are dozens of unmaintained implementations. So if you go on OAuth.net, where Aaron has listed all the libraries for different languages, if you click on them, like every second of them last update 4 years ago or something. Yeah, and interestingly, this lack of good libraries is like a what's it called? Self-fulfilling prophecy. Thank you. Because we have this lack of libraries, we as an offerer of an API, we have to document every single request, every single response, how to process it. So we have to write a complete documentation on the HTTP level. And this leads developers to just implement it this way, because they have this implementation. They see, okay, it's just a few requests and responses. What could go wrong? So they just go and implement it themselves. So there's no real incentive for them to learn how to use a library with that. Okay, why do I keep hiding my phone in my pocket when I need to switch slides? And then there's what I call the OAuth configuration hell. Assuming you don't have server metadata, then you need to figure out a few things until you can use a library. Yeah, I know, but I need to have a handful. So maybe I had an Italian somewhere in my ancestry. I don't know, but the Auth configuration help. So just to set up a library without server metadata to use Auth, you need to figure out like dozens and dozens of things, like what are the endpoint URLs, authorization endpoint, token endpoint, if you use OpenID Connect user info endpoint. What are the supported grant types? What method of client authentication is used? What are the security mechanisms you should use or can use or must use? Sometimes you want to use a security mechanism, you don't even know if you can use it. And this is not even talking about the specifics of the API itself. So you still have to figure out what are the scopes, claims, and so on. Yeah, so without server metadata, this is a really tedious process. And this also reduces the value in using libraries. Because if you have to figure out all of this yourself, then maybe it's just easier to implement the HTTP requests. What are the consequences from this? Well, there are plenty. First of all, there's an unnecessary fragmentation. So the libraries only support a specific subset. It would be great if they could just support a larger feature set, and maybe then we don't need that many libraries. This also leads to a slow adoption of new specs. So we have recently standardized the issuer parameter and the authorization response. This is a really, really small change. But I don't expect to see that in any of the libraries soon, except for Philip's library. Thank you, Philip. And this can lead to developer frustration, except for those using Philip's library. So to quote Hans-Jörg here, if I may quote you, he just, was it yesterday? No, the day before yesterday. He said that when they implement an OAuth client, they usually count several hours of research or do several hours of research before actually implementing something. And this is not a good situation. If you, this is completely unscientific, but if you take a look at Twitter, and this is only from one day, so I just opened Twitter, search for OAuth, and if you do that, you find many, many voices from developers who seemingly spend hours and hours of configuring OAuth. So part of this is the OAuth configuration. And I really wish that for a developer, the only thing that they had to do was to throw an issuer URL into a library, and then off they go. Of course, still having to implement some specifics for the API, but we are far from that when you count the voices on Twitter. This, of course, also costs time and money. So we see this with our customers who often spend a couple of days developing the integration until they get to the point where they can actually use the data that our identity providers provide. Also, for those offering the APIs, if you offer an API and you want to provide an SDK for that API, you often also have to maintain what is essentially a specialized OAuth library. And it would be great if we could come to the point where you, just as you don't implement TLS or HTTPS today, where you could just use a library that's already there in your framework, in your language, and use that to integrate with OAuth. API providers also have to spend a lot of time just explaining what they are doing. It's standard OAuth, so they have to explain it over and over again. And they have to support developers who don't understand OAuth, but maybe they shouldn't be required to understand OAuth. They should just be able to use OAuth. Yeah, and then, of course, the developers, they have to do trial and error to figure out what is supported in a certain API. I here used Twitter as an example because Twitter just recently created an OAuth 2 API. And this is very interesting because this is not a legacy API. This is new. They support Pixie and so on, so it's okay from the security profile, perfectly fine. But if you read the documentation, it's interesting that you see that they expect all developers to essentially implement this from scratch. So they talk about, they have a glossary with OAuth terms. They explain the OAuth flows, and they also have an explanation for every single parameter that you use. And one thing in particular struck me. So they give an example for an authorized URL, and they even say, you will need to have the proper encoding for this URL to work. Be sure to check out our documentation on the % encoding. Why do we have to do that?
Yeah.
I mean, we're not explaining TCP to them either. So this should not be required. But I know that this is a problem, so I understand why Twitter put it there, because we have the same problem with customers implementing yes. So yeah, there you go. Yeah, and obviously my favorite topic, security. Custom implementations are obviously also bad for security. So there are many, many opportunities for hidden security problems. So when I see customers implementing our APIs, I sometimes have the feeling that they probably don't do all the security checks they should be doing. But it's hard for me to check that because I cannot look into their code. I don't have the time to check their code. But you can just hide a lot of security problems in a custom implementation. If there come new security recommendations, it's unlikely that custom implementations will follow them. And of course, we have known anti-patterns that are still being used, like state being filled with a static pattern. Also Pixie being used with a static code verifier code challenge. So there's some research, I took that from an older presentation, but I guess this is still more or less current. Researchers have spent some time to look at actual OAuth implementations, and they found security problems in almost all of them. It's like sometimes they had like 96 clients that they looked at, and almost all had security vulnerabilities. Again, this is a bit older, this research. I guess there's not so much new research on that topic because it's the same picture again. Yeah, so let's discuss some solutions. And when I say let's discuss that. But I'm going to make some proposals, maybe as the basis for the discussion. Proposal number one would be to define a goal. Because currently, when somebody starts implementing a library, or when somebody has a library and asks themselves what could be the next feature that I implement, there's no guidance that we provide. Maybe we can provide like defined levels of support, defined feature sets, something like that, something with a label on it, just saying, okay, this is, I don't know, Auth, super duper compliant, whatever. This can be based on existing profiles and specifications, so maybe we can reuse or attach this somehow to Auth 2.1. Maybe you can use FAPI as a guideline, something like that. Or we could just stay within a very narrow context with the core Auth plus Pixie plus something else, and just say, okay, there's a they're mandatory to implement features for a certain profile. And I like that OpenID Connect does the same thing. So you have mandatory to implement features for all OpenID providers, and you have mandatory to implement features for dynamic OpenID providers, and more places like this in the spec. And this is, of course, then the basis for conformance testing. But I think before conformance testing, even, it would be important to say what we expect from a modern, good, and universal OAuth library. Number two is to make metadata mandatory, or mandatory in the sense that we expect it from any modern implementation. Because OAuth metadata enables libraries to automatically configure themselves to figure out what are the security mechanisms, endpoints, and so on. And this can greatly reduce the friction that you have in implement OAuth. And I hope that this also does away with the OAuth configuration hell. So that reduces development time and costs, and it also increases the value in using libraries, because if you have that and you can just throw a library on it, there's no incentive to write the OAuth flow yourself. And yeah, hopefully the libraries can then also adapt to just using automatically some new OAuth security features. Yeah, therefore, I propose that this is, becomes mandatory in OAuth 2.1 and also generally that we expect this from modern OAuth implementations. Then there's number 3, maybe the elephant in the room. It would be great to have something like conformance tests. Based upon the profiles that we define or profiles that are there already, we or somebody else could provide conformance tests. This is a great thing of the OpenID universe. It really helps to ensure that implementations are standards compliant. Obviously, we could also ask the IETF protocol police, which was established on 1st of April 2021, to do that for us. Yeah, so
we reissued that RFC.
We reissued it. Yeah. So there are many open questions. Obviously, when we want to go in that direction, that's something where I hope to get input from you, and yeah, where we need to think about. Do I have something else? No. I'm just asking for other ideas. And that's the moment where we can open the discussion.
Thank you, Daniel. Great presentation. Vittorio.
Oh, he took notes.
Vittorio Octa. So I have to apologize for the huge rant that is about to flow from this microphone. But I've owned SDKs for identity and developers for a few years. So I have very strong opinions about some of these. And I'll start the shit sandwich with good things, as in, I think that the conformance test is a fantastic idea. Would be interesting to see what it looks like, because Auth is so protean, but it's a really great idea. And anything that in which you can like put a label on the library and say, this library supports X, Y, Z, along the lines of what you're saying, so that it's a bit more predictable, plus user metadata. Fantastic idea. That's it. Talking about Auth libraries is a bit misleading. Normally, the libraries are there to help people to perform some kind of goal, and that goal is usually removed from the protocol level. Like when we operate at the protocol level, we are doing something which is pretty fine-grained, and it doesn't usually map with the jobs to be done. Like, for example, people do sign up all the time using those flows, but we don't ever talk about sign up. So there are like things that the developer, the normal person, think about when they're trying to perform a goal, a function, and similar, which will happen to use Auth, but between Auth and the function that they want, there is a delta. And so often the SDKs don't expose the low level because the developer would not be able to do it. And so depending on all the things that are between the top level and Auth, it might be hard to do it. Like you'd have a counterpart of Intel inside, in which you don't need to know the details of a prefetch pipeline, and you just say, I like that if there is Intel, but the library, you should expect that a lot of libraries will operate at high level. Then there are, like when we say Auth, we mean so many different things. And in general, if you look in terms of jobs to be done, there are resources, as in when you say, people say Auth instead they are doing OpenID. That's because they're trying to do sign-in. And then at that point, the highest availability is sign-in as the resource or the API versus the requesters. Those are vastly different animals. And although when you do resources, you can approximate some of the things that you're describing, as soon as you're a client, there are huge individual differences that every provider do, which have a big impact on the quality of life of a developer. The Microsoft people have a resource, refresh tokens that can be used with multiple resources. Others don't have that. Or they have a mechanism for the metadata in which you can express multiple tenants. And there is a proprietary mechanism for selecting between those. From a developer point of view that wants to get the job done, the fact that this thing is not strictly conformant doesn't matter. For the person that tries to sell the service which is required for that, the fact that it's not conformance doesn't matter. The metadata mandatory stuff. We are lucky that Apple decided to more or less use OpenID Connect. But despite we pleaded and prayed and threatened, they are not supporting the discovery endpoint, and probably there are strong reasons to do so. In the market, people want to do sign-in with Apple, so the fact that they don't support it is just the way it is. In terms of library, I didn't understand if you were suggesting that we would for example, start the process of building libraries ourselves somehow or bless them. I think that the up-off example is a good example of when you try that initiative, it's difficult to sustain it over time. And it also shows an interesting drifting toward the proprietary, because Google was the main proponent, but they still had a special flavor of their library for the reasons that I said earlier, because people want to be productive with Google, and so they add layers on top of it that are not strictly for the spec. And that's it.
Thank you. So two things. So regarding the last point, I don't think we should ourselves be producing libraries. I don't think that will bring us somewhere. So
Stop it, Philip.
Sorry. Stop immediately. No, blessing them or something is something else, but we shouldn't be producing the code ourselves. The other thing that you raised, and I think that's a very important point, there's not always the one use case. Maybe there's a use case where, there's a use case that is quite common to many of the libraries, like a sign-in or just getting an access token, the easy case. But I imagine that any library can also be created in a way that you can dig deeper. So when I compare to HTTP libraries, for example, there's usually a very easy way to send a GET request, and I get the response body, and that's it, right? Maybe there's a way to do the same with a cookie, so maintain a session with the server when I'm sending 2 or more requests. But usually I can also say, okay, please add a header to that specific request. Please change the encoding of that specific request. Or here I want to use, I don't know, I put some JSON into this, please handle this for me. So I think there's a way to write libraries where you can dig into all the details, which you can then use to send very specific requests, maybe also stuff that is far from the core of Auth. But I think developers shouldn't have to do that. So just as an HTTP library, I'm not sure when I last wrote something where I sent bare HTTP headers over a TCP connection. That should just not be required from a developer. So, and in the same spirit, OAuth users should not be forced to implement HTTP requests themselves, and they shouldn't be thinking about encoding if they don't have to.
Okay, Justin.
Justin Richards. So a couple of things here. One, I want to echo Victorio's point that the use of an OAuth library is always contextual. And while technically you could also say that HTTP use is also contextual, it's not contextual in really the same way, because the applications that you're building on top of HTTP kind of mostly don't care about the HTTP itself. The OAuth stuff is a really brilliant abstraction of the security properties of APIs, but it is not a complete layer separation of those properties. And 2 direct examples of this that I think inform this. I will start by saying that I absolutely hear where you're coming from, and I also wish the world were better. I think that there are a few things that are stopping the world from being better, though. The first problem is OAuth itself. It is not a single protocol. So writing especially a client library for OAuth means at least 6 different things depending on which flows you're doing. I, for a while, maintained a Java implementation of a client library that could do all of the OAuth stuff for the auth code flow. And we routinely had people coming in saying, like, make it do the implicit flow. And we were like, no, it's a web server. That's a different thing. We're not going to do that, right? And so that is going to be a consideration for any OAuth library. Just the use of it is going to be drastically different depending on which flows you're doing. The second thing is that ultimately developers really want to have, they want to get to that end state. of doing the thing that OAuth is protecting. And we saw that, well, Antonio Sanso and I saw that when we were putting our book together originally it was a few years ago now. We went out of our way to make sure all of our examples were not provider specific. We were not talking about Google or Facebook or GitHub or anything like that. The first review that we got back in during the like the copy review phase with our publisher, somebody said, "This is useless. It doesn't tell me how to connect to GitHub. So you need to throw out all of the examples and write, how do I write a client to connect to GitHub? That would be a useful book. This is garbage."
Yeah.
No, it actually had nothing to do with the specifics of that. They were mad that all of our examples were not pointing to github.com specifically. Right? It actually had nothing to do with like hands-on implementation. The quirks of things like that, totally a different thing, and Vittorio covered that. But the point of this here, though, is that the end users of libraries of this, developers, ultimately want to just go and do the thing. And so, in my view, this good general purpose library suite that you're describing, the actual end users of that would be people who are more SDK developers than anything, right? This is the stuff we would want to be included in a package that speaks a protocol. And that is a very different type of thing to architect for.
Okay, thank you. Mike? We have a long list of people waiting, so I want to kind of allow them to give them a chance to say something, right?
Yeah.
Okay.
As a practical matter, for instance, in the Connect world, because we have a certification program, then we can host a list of certified implementations, which perhaps Joseph will speak to when he hits the queue. And so we have a quality bar. As Daniel pointed out, there is no quality bar for OAuth implementations. But we could list quality implementations. I do note that a prominent member of our community, Aaron Parecki, out of the goodness of his heart, hosts OAuth.net, which among other things has OAuth.net/code with a whole bunch of implementations on it. And I'll just ask Aaron to speak to that and what is already happening for the community. Thank you.
Thanks, Mike. Hans?
Yes, this is Hans-Jörg from Outrigger. I just want to make 3 short points. First point, appreciate this discussion here taking place. I think it's not so usual for any working group. Second point is, I think issues raised here are kind of generic to some other IETF groups as well, right? So it's about a very general thing about an RFC being out of context when you Google it. So there might be something like a sidebar referencing libraries or whatever kind of stuff. Maybe that's worth one idea. And third point is basically adding to some of your examples, basically. So I think there is one more point. It was discussed that OAuth libraries might be included in SDKs. Yes, probably. Point is, it's already right now to a certain extent. So typically, if you deal with some Google or Facebook or so things, there will already be OAuth functionality within the SDK. Whereas for some less known providers, you will need to use some general purpose OAuth library. And this is actually also a practical problem, in my opinion, because not that you need to do OAuth with different libraries, it also makes the handling less generic in a way. And there is, for instance, security problems. I mean, most of the security problems seem to relate to cross-site scripting and so on. But for instance, there's also a problem of maintaining OAuth credentials on the server, for instance, which gets much more problematic if you have different ways of, how libraries read the secrets and so on. And also there is stuff like, what do we do about refreshing tokens and this kind of stuff? Yeah, so it's operational stuff you need to do, logging, that kind of stuff. That gets also quite difficult when you have, multiple libraries you need to support. So maybe it would be even nice if SDK developers would think about offering a way besides what they have included by themselves, to probably get a token from a third-party library included, so there is some interoperability.
Thank you. I'll ask the rest of people in the queue to be a little bit quick so to allow everybody to get into market.
Uh,
Peter.
Peter Castleman, Microsoft. So I think a couple of things. As we've been looking at implementations, one of the challenges that we see is that there's a lot of mistakes being made again and again in terms of implementation. To Mike's point around the quality bar, I think anything that we can do in terms of defining a target and a set of acceptance criteria or test cases and implementations, and whether we put certifications next to that, that's a separate discussion, but very supportive of that idea of helping to just improve the security profile by having at least some standard test cases and a profile to aim for.
Thanks. Thank you, Peter. I think Joseph. Joseph, can you hear us?
Sorry, I had extra prompts pop up. Yeah, so I mean, I agree very strongly with everything Daniel has said, and I could talk about this for a long time. There's some weird stuff out there. I've seen vendor documentation that really strongly encourages people to just generate one Pixie challenge and code verifier and to use that always. I've done a lot of work in open banking. Sorry, I forgot to say my affiliation. I'm either Auth or OpenID Foundation or both. Yeah, even in open banking, a highly regulated industry where there's quite a regulation that applies to the clients. Security is like 8 or 9 on the list when people are implementing clients, and they just don't get to it. Some of the checks just don't get put there. We've seen that across multiple ecosystems. I mean, I think the profiles and insisting on metadata absolutely makes things a lot easier. FAPI insists on metadata, and that's made such a difference to everything. As you know, I'm heavily, some people know I'm heavily involved with the OpenID conformance program. That's a great program, but getting a library through that program is definitely not a non-zero effort. It does require some determination from the developer. So it's not just about providing the tooling. There's more of a problem here. And I think, as a few people made the point about these SDKs, yeah, a lot of the OAuth clients do get incorporated into the SDKs. There are an awful lot of SDKs that have very poor OAuth client implementations in them, and that they have filtered through. That's one of the reasons for the horrendous stats about apps that Daniel showed, is that there's a lot of apps that are all using the same SDK that's very bad. So I mean, I think one of the ways forward here has to be a kind of collaborative effort of all the authorization server vendors, where we agree that this is a direction to go, and we each individually put effort into tackling one piece of the problem and making sure all our documentation says consistent things that, look, go here, don't implement the protocol from first principles, because everybody's documentation, like Daniel says, it goes right back to first principles and often doesn't mention libraries, even for the places that there are actually good libraries. So okay. Yeah, I'll stop there. Thank you.
Thanks, Joseph. Thank you. Dave.
Yeah, hi. So yeah, I just to agree with what Joseph's saying, what Daniel's saying, I disagree with what Justin was saying about kind of there's too much, different context, and this needs to, and this is just for maybe SDK authors. Yeah, definitely. The big providers who make SDKs, if they can use these libraries, that's excellent. But I actually think the normal thing should be, like Daniel said, you don't re-implement an HTTP library. Hopefully you don't re-implement a JOT library. If the scope is restricted enough, you should be able to just use an OAuth2 library. So I've yet to hear a convincing argument why that's not the case. And sorry, yeah, my affiliation is MoneyHub, and with our own SDK, yeah, we just use Philip's library, and it's very, very easy. So yeah, very strongly in support of Daniel's suggestions.
Thanks, Dave. Aaron, hold on, Aaron, 1 second. Daniel, do you want to say something?
Just really quick, adding to that discussion here, maybe there's an 80% use case. So maybe 20% you can't cover with the library, and maybe that's fine. But I feel that there's like an 80% use case here where we need to think about.
Okay, Aaron, I'll give you a chance. 1 second, just Aaron.
Yeah, I just wanted to, thanks for teeing me up for that, Mike. I just wanted to say I'm happy to do
to put some more work into the OAuth.net site, OAuth.net/code in particular, to better highlight the libraries that are there. Right now, it's pretty much a list that I've chopped up and encourage people to contribute to, but I haven't done a lot of, I would say, maintenance myself on it in terms of like auditing existing code. And I do think one of the challenges of that is that there's a lot of options available for any particular OAuth implementation. So it's hard to sort of say, here's the stuff that you have to do and here's when you're done. So definitely a conformance test would help with that, but that is a whole topic by itself. But yeah, I just want to say I'm happy to take suggestions or do some more work on maintaining that list.
Awesome. Thanks, Aaron. Justin.
Super quick. I wanted to appreciate that Dave came on to disagree with me and then proceeded to basically make all of the same points that I just made. Because really what I was talking about is that when we're talking about these generic things, the target of this is not the same as, like a lot of general libraries. You're building this to be embedded into something, and that is a different kind of architecture and set of considerations that you are evaluating for and that you're designing for. And that was really the main point, because by building into an SDK, like even it doesn't have to be like a large provider, like, hey, here's Google, here's how to talk to Google. It's, oh, there's an API that I need to talk to, and I'm going to build a module in my code that talks to that API. Give me something that does the OAuth stuff. Yes, I would love to have lots of those things across lots of different platforms available. I think that would be very, very, very useful. I just don't think it's quite as universal as we would like it to be. And that's the point I was trying to make. Okay. Not that this is a bad idea.
Thank you. Sorry, Vittorio. We need to move on. Daniel, do you want to just wrap it up? And then we will switch to the other one. Okay.
Yeah. To wrap it up, I do have one more slide. So thank you all. I think this was a great discussion, and I'm looking forward to following up on a mailing list. There's a thread already, so it would be great if you could put your ideas into an email.
Yeah.
So that we can.
Yeah, definitely. Thank you all for the great feedback, great discussion. Let's continue that and see what could be done in this area. Let's switch to the last topic here very quickly.
Please stay seated.
Yeah.
Until the plane has reached its parking position.
I'm gonna put you off first. And which one is this?
Pixie. The Pixie and these ones.
Yes, there you go. Share.
Yeah, so this is essentially a repetition from an informal session.
Give him control.
So yesterday we had yesterday and the day before yesterday we had a discussion in the informal meetings here at the IETF meeting regarding the role of Pixie in the security VCP. So yesterday I created these slides, so I'm going to go over this really quickly. Pixie is in your security VCP and is recommend or must in many cases. And the reason is that Pixie is a really, really good tool. Pixie provides CSF protection, so it can be used instead of state to protect clients against CSF. Pixie is also a protection layer for authorization codes, and that's the main reason we made it a must in many cases in the security VCP, with the alternative of using the nonce in some cases if you're using OpenID Connect. There are essentially two different attacks that we're talking about here. The first one is an attacker sees an authorization response, sees the code that is in the authorization response, takes the code, goes to the token endpoint of the authorization server, sends the code, and gets back the access token. So the attacker ends up with an access token. This is bad, but the attacker can only do that if we're talking about a public client, because with a public client, there's no client authentication at the token endpoint. Okay, So for confidential clients, for a long time, the belief was that if an attacker steals the the authorization code, that the attacker cannot do anything with that. However, the attacker can do what I call authorization code injection. That is, the attacker can take the authorization code and on his own device start a new session with the same client, do the authorization request response, and in the response exchange the original code with the stolen code. So essentially providing the stolen code to the same client. The client will then use that code on the attacker's behalf at the token endpoint, providing the authorization client authentication. And the attacker will therefore have control over a session with the original client in which the code was used that was stolen from another device, from a victim. The attacker only has to do that when we're talking about confidential clients, because for public clients, there's an easy attack. Now, the thing is, if you have confidential clients and you do this code injection attack, both Pixie and nonce prevent this attack. If you have a public client, no client authentication, and the attacker can go directly to the token endpoint, then only Pixie can prevent this attack, because the attacker would have to provide a code verifier, which he cannot know. Therefore, we created a nice table, or Aaron created a nice table, thank you, Aaron, showing what you see here. Not going through all the details here. The thing is, CSF can be parented by both Pixie and nonce, that's fine. But if you have a public client that uses response type code, then only Pixie can provide protection if the code is stolen. Therefore, we say in the security BCP that for public clients, Pixie is a must, because it's the only layer of defense that we have in case the code gets stolen. Okay, and yesterday we agreed that we keep this in the, so this is the wording, not going through all the details, but that we essentially want to keep this wording that we have in the security BCP. That's not the slide, next one. Hello? Is this the old slide set?
I think.
Maybe.
Yeah.
Okay, so yeah, I sent one today.
It's okay.
But it's fine.
You have to talk.
I can talk. Yeah. So we agreed to essentially keep the wording. What we'll be doing is we are going to explain what I just explained and what is on the slides better in the security BCP, because it took us a while to figure out why we wrote this in the security BCP. That's not a good sign. And also some changes on the wording in the details, because the attack is not described at the right place. Mike has a comment on this.
Mike Jones, Microsoft. First, thank you for putting this together yesterday, and to Aaron. That was a good discussion. I believe there are cases where you're correct that code injection is not prevented. I have thought about some of the OpenID Connect flows, such as ID token, where you send a nonce, you get back an ID token in the front channel, you get back the code in the front channel, and you use
token.
And you use, yeah.
You said ID token. So it's also token in the front.
And also ID token code. Yes, I said the wrong thing. If you're using ID token code, you get the ID token with the nonce in it to check. You have a C hash in it to check, and so the attack is prevented. Not for the code flow, and I agree with you. And I'll just repeat for the minutes here, I am volunteering to work with Daniel and the other authors on language, trying to help developers understand exactly when this is essential and when there's other mitigations. I'm not changing the basic conclusion. But like much of this, it's subtle, and it depends upon when you're getting the cryptographic hashes of the things and when you're not.
Very briefly to this, in this case, the code is already leaked to the attacker, because we assume the authorization response leaks to the attacker. Attacker has the code and can just use it in the token endpoint. So C hash doesn't help. The ID token, so nobody would accept that ID token, right? But the attacker can just use the code and go to the token endpoint. So that doesn't help in this case.
You check the ID token against the nonce, you check the authorization code against the C hash, and so it's impossible to inject the code.
Are you guys trying to find out whether there's some cases in OpenID that would also need to be sort of
Yes.
like additionally improved?
Whether we can narrow down the cases where the Pixie would be a must. But I don't think this is one because there's no client involved after the attacker.
Anyway,
the code. But, yeah.
we will work on this. My point is there's
Yeah.
still
Yeah, yeah.
details to work out.
Great. Aaron. Just give Aaron. And I'm going to close the mic after that. So.
I just wanted to say that to Mike's point, there are two different attacks being talked about here. So the code injection is the attack that is prevented by the C hash, but stealing a code and using it at the token endpoint is not prevented by the C hash because that's a thing that the client is using to protect itself. So two different attacks, and that's why I was trying to make that table, which it got more complicated than I wanted it to be, and it maybe not be clear enough yet. So we need to work on that still.
Awesome. Thank you, Aaron. Daniel, thank you for two great presentations. Do you want to wrap up or good?
Yeah,
Okay.
wrap it up. So it was nice to be here. Thank
Okay.
you, everybody.
Indeed, it was great seeing you all, and hopefully we'll see you in Philadelphia. Thank you all. Bye. Great. Awesome.